assessing how those carbon nanotubes grow in a very small contact hole. Another example is shown here, where we've developed some unique 3D TEM tomography technology, which allows us to, in very much detail, characterize some of these 3D nanowire type devices at the nanometer scale. This, I think, is really world-unique capability that we have developed at imec, and that allows us to put a lot of fundamental understanding when we are assessing these kind of new device structures. This we are combining with a lot of process modeling, process and device modeling. We're working with several of the major TCAD vendors in using their tools in order to apply them to those advanced devices. But we're complementing that also with some of our own solvers that we have optimized to really deal with these ultra small nanometer scale dimensions and taking into account some of these new materials such as InGaAs and others. We also have a very strong focus on the fundamental understanding of some of the conduction mechanisms, explaining the conduction mechanisms in some of these memories, such as in our RM program, for which we are developing specific models describing the conduction mechanisms in these filaments by oxygen atom and vacancy diffusion models in those filaments. Also in the back end, the thermal cycling, when we have this huge copper pillar in our silicon, the thermal cycling will induce stresses on the devices that will influence the electrical performance of the devices. So we have to understand this and interact also with our design people in order to understand how it will have an impact on the way how we design circuits with those copper pillars. Now, of course, in order to benefit from those